With percent of a field problems, you need to clearly identify the area of the inside and outside of the rectangles. Be careful with percents. And find out if it's talking about the small area, the big area, or the frame. In example 1, a man mows his 40-foot by 50-foot rectangular lawn in a spiral pattern starting from the outside edge. So we're moving inward. By noon, he is 90% done. So 90% of the field is this part here, the white area. And the green part is what he still has not mowed. That would be 10%. If we need to know the total area, that would be 40 times 50, which would give us 2,000. If we want to know the area of the 10% that's left, that would be 0.1 times 2,000, which would equal 200. As you may recall, length times width equals area, and we can define that area in the middle by subtracting 2x from both the 40 feet and from the 50 feet. So, 40 minus 2x times 50 minus 2x will give us the area left inside the 10%, which we know is 200 square feet. When we FOIL our binomials, we get 2,000 minus 80x plus minus 100x plus 4x squared equals 200. From here, we can add like terms in the middle, and we get 2,000 minus 180x plus 4x squared equals 200. Writing our terms in order of descending exponents, we get 4x squared minus 180x plus 2,000 equals 200. Subtract 200 from both sides, and we get 4x squared minus 180x plus 1,800 is equal to 0. We can divide out the common factor of 4 in all the terms in the equation, which gives us x squared minus 45x plus 450 is equal to 0. Factoring, we get x minus 15 and x minus 30. Setting the factors equal to 0, we get x is equal to 15 or x is equal to 30. Obviously, if we subtracted 30 from both sides, we'd end up with subtracting a total of 60, which wouldn't make sense in this problem. So we toss out 30 and keep 15. So the the width of the piece that he's mowed is 15 feet. In example 2, we have a woman who has a 50-foot by 25-foot rectangular field. If we want to know the total area of this field, it's 25 times 50, which equals 1,250 square feet. It says that she wants to increase by 68%. This means we want the bigger area to be 168% of the original area. So, we multiply by 1.68 times the 1,250, which was the original area, to get the new total larger area, which is 2,100 square feet. From here, all we need to do is define the new total area of the rectangular field. Length times width equals the new total area. So we need to take 50 and add 2x to it to define a little more room here. 50 plus 2x would define this dimension, and 25 plus 2x would define this dimension. We know that's equal to the total new area, that's the larger area of 2,100 square feet. Now foiling, we get 1,250 plus 100x plus 50x plus 4x squared equals 2,100. Adding like terms, we get 1,250 plus 150x plus 4x squared equals 2,100. Subtracting 2,100 from both sides, we get, in order of descending exponents, 4x squared plus 150x minus 850 equals 0. Dividing by a common factor of 2 on each side of my equation, I get 2x squared plus 75x minus 425 is equal to 0. From there, I factor. This is such a large quadratic equation, I'm going to use a quadratic formula. X is equal to negative 75 plus or minus the square root of 75 squared minus 4 times 2 times negative 425. All over 2 times 4. This is equal to negative 75 plus or minus the square root of 5,625 plus 3,400 all over 4, which equals negative 75 plus or minus 95 over 4, which is equal to, the positive solution would be 20 over 4, which is 5, and you can't have a negative solution. This is my new answer.